Okay, this video will help you with Miss Kim's version of this study guide test. All right, here we go. So for this first one, you're evaluating. That means I'm taking this -5 and I'm plugging it in there for x and doing the math. The way we want you to show it is f of that -5. That shows me what I'm plugging in equals 2. And then right here is where I plug in that -5 and actually start to do math minus that 1. That gives me 2 times -5, which is -10. And then subtracting that 1 gives me the function at -5. When I plug in -5 for x, gives me -11 for y, or f of -5 equals -11. For this guy, just going straight down, this one I'm replacing that for t, but don't worry, when I replace that, that fraction is going to go away. So for this one, r of -6, so plugging in -6 for t, is that -1/2, and then right there where that x used to be, I'm going to put a -6, and then subtracting that 6 from the original problem, knowing that this is a fraction over 1, knowing that this goes straight across and gives me +6 over +2, or another way of writing +6 over +2 is this turns into 3 right here. So again, timesing straight across gives me 6 over 2 positive, and that reduces to 3. So when I'm doing that, that madness becomes +3 minus 6 gives me r. When I plug in -6 for t, or r of t, gives me -3. If I could circle that. All right, plugging these in. This 3 is going to go in there for d. So this gives me c of that same 3 equals 15 minus 4 times that 3, making sure I do not time or do not add right here. Don't do that first. Make sure you times first. This gives me 15 minus 12, and now I could finally subtract. So c of 3 gives me 3, I believe. All right, moving on. Here we go. This guy, plugging in 5 into a, gives me s of that 5 is 12 plus 4 times that 5, making sure do not add these right here. Don't do that. Make sure you do this multiplying right here first. So that gives me 12 plus 20, or s of 5 equals, I believe, 32. All right, moving on. These guys, graph using x and y intercepts only. I'm going to do y intercepts in blue. I'm going to do my x intercept in red. So here we go. Looking at this. This is my y intercept. That's where my first dot goes. This number in front of x tells me where to go from there. So that -3 turned into a fraction tells me from that blue dot, every time I go right 1, I go down 3. Right 1, down 3. That's where my next coordinate goes. Right 1, down 3. Right 1, down 3. You could keep going, but remember, for this one, we want only the y-intercepts. So we want you to get rid of all these extra coordinates. We only want you to plot these 2 right here. So when all that smoke clears and I get rid of all my coordinates I do not need, this one's going to go. So I could unclick that one away. I could get this out of here so I could clean it up. So when I do that, right 1 down 3, right 1 down 3, right 1 down 3, my final dot is right here on 3, 0. So take my line, draw a line through those. Make sure your line is nice and long and not short. Make sure you have double arrows on each side of that line, and I'll make it a little bit thicker so you can see. All right, so there we go. All my y-intercepts. This one, x is 0, 0, 9. This one has y is 0. This is 3, 0. All right, next one. So my y-intercept would be 0, 9. My x-intercept would be 3, 0. Knowing what those actual coordinates are. For the x-intercept, the y number is always 0. For the y-intercept, the x number is always 0. All right, here we go. For this one, starting with my y-intercept of -6. Doing this the slope-intercept method way. So this is 2 made into a fraction, right 1 up 2. So right 1 up 2, right 1 up 2, right 1 up 2. It looks like that is where my final dot is going to go. I'm going to make sure that I clear off these other dots because I only want the x and y intercept. Only those two, that blue one and that red one. Draw a nice straight line through those dots. Put double arrows on your line. Make it thick. Write down those coordinates. This x-intercept is 3, 0. The y-intercept is 0, -6. And if you remember the algebra I showed you for the y-intercept, where x is always 0, remember? You could show this algebra by taking that 0 and plugging in where that x is. So that tells you f of x, which is really y in disguise, gives me f of -0. So that gives me -6, or that's really y equals -6. So when x is 0, y algebraically shows me -6. For the x-intercept, that's where the y number is 0, not the x number, the y number. So for this guy, I would be plugging in my 0 right here where that y used to be. And then for this guy, doing the math as is, I'm going to add 6 and I'm going to divide by 2. That gives me the x number. All right, algebraically. All right, moving on. These guys, we want you to solve the system by graphing, and we want you to only plot the coordinates. So on the graph, on the test, they want you to only graph the solution coordinates. So for this guy, starting at -5, and then looking at this 1 right here, which is 1 over 1, which means from that blue dot, -5, every time I go right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, be able to staircase opposite way, down 1, left 1, down 1, left 1. That is my blue line right there. And when I do my red line, this one, let's do that blue line again. So drawing a nice straight line through those coordinates using my straight edge, making sure I got an arrow on each side of that line. Showing that line goes on forever. All right, this one in red, starting at -3 down here. This one's slope 2 over 1 means from that I'm going right 1, up 2, right 1, up 2, right 1, up 2. Be able to stair step opposite, left 1, down 2, left 1, down 2. I could see that is where they intersect right down here. That's a tricky one. And then when I draw my line through those red dots, you're finding where those two lines intersect. And I can see right here where they touch. If I write that x and y coordinate for that answer, it looks like I'm going left 2, so the x number is going to be -2 to get to that touching spot, and then from there going down 7 to get to that. And then just remember on the final, They only want this dot. They only want you to plot the coordinate where they touch. All right, moving on. This guy. This one looks like I'm starting at +4. And then this one being -1 tells me right 1, down 1, right 1, down 1 from that 4. Right 1, down 1. Be able to stair step opposite way. Left 1, up 1. Draw that line nice and long. All right, one in red, starting at -3. And now that number in front of X, that 1/2, that slope number, that rate of change, that ratio tells me right 2, up 1, right 2, up 1, right 2, up 1. Be able to stair step opposite way, down 1, left 2, down 1, left 2. Looks like these are not intersecting at a nice, neat grid. So I'll double check my work. And then we might have a little fraction in there. Or a decimal maybe. All right. So starting at 4, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1. That graph looks legit. Starting at -3, over 1, 2, up 1, over 2, up 1. It looks like they're meeting probably about a halfway point. So for my X number, a little tricky, looks like that's about 4.5. And then for my Y number, that looks like about -0.5. That is a tricky one. I'm hoping I did that one correctly. I will stand back and double check. All right, moving on. This guy, where is the graph increasing? Increasing is where it's going uphill like this. And where it's increasing, I look at my X numbers to frame where it starts increasing from -8 to -6. I can see that's one stretch where it's increasing. It looks like from -6 to -4 increasing. So it looks like the only answer that has from -6 to -4 is this one right here. And I don't see that other answer from -9 to -6, so I'm only going to circle that one. All right, decreasing is where it's going downhill from there to there, from here to here, and then here's another decreasing section from -4 to 1. Looks like that one's not listed. From 1 to this 5 right here, that one's not listed. And then from 5 to 9, that one's not listed, but looks like the best choice would be from this 1 to this 9. From 4 to 9, it's also going downhill. From -1 to 9, it's going downhill. From -4 to 9, it's going downhill. So it looks like all of those apply. I mean, they're all going downhill from that stretch, from -1 to 9. All right, uphill, let's see if those other ones match too. From +1 to 9, nope. From -9 to 4, nope. From -9 to -4, yep, there's another one there. All right, here we go. Which statement is true? There's a maximum at 4.8. 4.8 is right here, so it's saying that's the highest point. This one's saying a minimum at 9, -4. Looks like that is a minimum coordinate. Looks like that one is good. All right, let's look at minimum -4, +9. That looks like that's the maximum, not the minimum, the maximum. Since that says minimum, that's not correct. All right, moving on. And let's just double check my answers. From +1 to 9, going up downhill. From -9 to 4, positive. Got a stretch in there. All right, let's just move on. All right, these guys, where is the graph increasing? Another one of these. So increasing from this stretch right here to here. And it looks like all my numbers are from this 3 to this 5 to this 7. So it looks like all my numbers from 3 to 7. That one's good. From 5 to 7. That one's good. -7 and -8. Nope. -3. Nope. All right. Decreasing. Here we go. Decreasing from here to here. This stretch also decreasing. This part is flat, so neither decreasing nor increasing. So from -9 to -4, all the way here to -2. Looks like those are my framing numbers. So from -7 to +1, nope. From -9 to -1, yep. From -9 to +1, nope. From 1 to 9, nope. All right, here we go. Which statement is true? There's a maximum at 7, 8. And it looks like right away that is the highest point. That is the maximum. That is true. Minimum at 8, 7. 8, 7. That's not the, oops. Let's see, 8, 7 would be 8, 7 would be right here, so not in the right spot, a little bit off. Minimum at -7, -1, which is right here, and there's nothing that matches that. All right, moving on. These guys write domain and range. So domain measured from left to right. Looks like this is going to -infinity. So it's going to be from rounded -infinity to this 7 number. And since that's an open circle, rounded. My range goes from, looks like square 1, 2, and then going up, +infinity, even though that's going to the left, rounded. All right, this guy, my domain left to right looks like from square -6 going to +infinity to my right. So +infinity rounded. My range going down -infinity for my range up here to 5 square on the y-axis. All right, moving on. These guys solve. So this guy, I'm going to take this and distribute it. That's going to give me -6x minus 10 plus 10x. I'm going to combine like terms. That's going to give me 4 of those x's minus 10. And now this is a variables on both sides. I'm going to start by getting rid of the number on the left. And when that number's gone, I'm going to eliminate that variable on the right, and then back to the left divide. This gives me -6. Now stay on this side and eliminate the 2x, and then go back to the right and divide. Gives me x equals -3. All right, 14, doing another one of those distribute, combine like terms. This gives me 6x minus 8 equals 5 minus 6x plus 3 plus 8x minus 5. Now on that right side, I'm going to combine all my numbers and combine my x's, my x terms. That gives me 6x minus 8. 5 plus 3 is 8. 8 minus 5 is 3. -6 plus 8. Let's do that first. That gives me 2x. 8 minus 5 gives me +3 when I combine my x's and my numbers. All right, now start on the left. Get rid of the number on the left, and then go to the right. Get rid of the variable on the right. Back to the left, divide. Get rid of the variable on the right. Go back to the left, divide. Showing my work vertical running out of space. Gives me x equals 11 over 4. I'm just going to leave it just like that. All right, here we go. Solving inequalities. I'm going to get rid of this 5. That gives me 4x less than or equal to 49 minus 5 is 44. Opposite, timesing is dividing. Don't change that inequality. It gives me x less than or equal to 11. If I do this one, start by getting rid of the plain number on the left. If I was you, I would flip this one around into negative 3x minus 4. Know that this little tippy tip is pointing towards the negative 3x chunk. So I got to make sure I write my inequality like this with my 5. Again, flip it around. Know that the opening is opening towards the 5. I can clearly see that. So right here, plus and 4. Bring down the negative 3x less than 9. Right here, the crucial step when I divide by negative 3. And this side turns from negative 3x to positive x. And the right side turns from 9 to negative 3. I have to make sure I switch my inequality around. I have to flip it around. All right, another couple of those. This one, I'm going to take away the 3. Bring down the 4x, the inequality, the 6x. This gives me negative 14. Stay on this side. Eliminate the x term. That gives me negative 2x. And then right there, the opposite, timesing by negative 2, dividing by negative 2 gives me x. Switch that inequality, positive 7. All right, this guy, taking away 7. Making sure to bring down this negative with the 6x. This gives me 42. Right here, I'm dividing by negative 6, which is going to take my inequality and switch its direction around. So 42 divided by 6 gives me negative 7. Switch that inequality because I divided by a negative. All right, for this guy, solve for m right here. So if I'm going to solve this for m, I would say flip this around. I'm going to add that 30. And I'm going to divide by 4. So that gives me 4m equals k plus 30. And now I'm going to divide by 4. So that gives me m equals k over 4 plus 30 over 4, since that can't be reduced. All right, this one I'm solving for t. So again, I would flip it around so it's an equation you're more used to looking at, a two-step equation. Here I'm going to take away 6, and then I'm going to divide by negative 2. That gives me d minus 6, dividing everything by negative 2. That gives me t equals negative d over 2 plus 3 when I use my negative rules. All right, here we go. For this one, select one that is not a function. Explain how you know it's not a function. All right, so here we go. Looking at my input numbers, do they repeat? None of those repeat. That's a function. If I look at these guys, my x numbers repeat. That's not a function. That one is not a function. Why? Because I have an x number repeat and give two different y numbers. Can't have that. This guy, my x numbers, none of them are the same. None of them repeat. That's a function. This guy, looking at my x numbers, my input numbers, I have two of these right here that shows an input giving two different outputs. So pick one that's bad and explain how you know. So I could say, I know D is not a function because an X value gives two different Y values. And I'll list those points to show that. So -5, -1, and 5, 0 can't have the same X. You have two different Y numbers. All right, moving on. 22, looking at these. These X numbers do not repeat. So that's a function. I'm going to find one that's not a function looking at the instructions. These are the X numbers. Seconds are always the X numbers. Y are here. So again, when you have a graph, always time is going to be on the X axis. If you have distance, that's going to be on the Y axis. So these are my X numbers. None of these repeat. That's a function. It doesn't matter that the other numbers repeat. And then I look at this guy. This is my input numbers. Those are my X numbers. These are my Y numbers. I have an X number 3 give two different Y numbers. That is not a function. Why? Because I have a 3 spitting out a 4 and then another 3 spitting out a 2. You cannot have that. So you could say the input output table is not a function because a Y value, an X value, or a X value is two different Y values. And that would be these coordinates right here. All right, moving on. This guy, what is the domain? The domain are the X numbers. So I can see for this coordinate, there's a 1, there's a 4, there's a 7, and then there's a 10. So domain are my X numbers. Range are my Y numbers, but I'm not asking for range. So 1, this one, 3, 5, 7, and 9. All the X numbers for those coordinates. Range are the Y numbers, but that's not what we're asking. All right, moving on. This one shows a domain left to right. This is rounded and infinity. So I'm looking for something like that. So if I'm looking at this guy, this one is definitely rounded 1 to positive infinity. So this one is good. This guy starting at square bracket 0 to positive infinity, no good. This one starting at 1, and even though it's going to the right, that is positive infinity. So there's another one that matches 1 positive infinity. This one is 1 rounded infinity positive. Nope. This guy is another rounded 1 infinity. So this one, and then looks like there's no infinity on this guy. That's a tricky one here. This one goes from rounded 1 to square on that 9. So almost, but no arrow. And then this one goes 1 to 11 rounded. So looking at that, the only one with positive infinity are the 2 I circled. The other ones do not match. All right, this one. Looking at words that describe this. So these are dots. So that means it would not be continuous. It would be discrete. This is going downhill. So it would not be increasing, it would be decreasing. And it is curved, so that makes this exponential. Linear is straight. All right, let's look at these. This one, no dots. So that is continuous, not discrete. It's going uphill. So that is increasing, not decreasing. And this line is straight. It's not curvy, so it's not exponential. Linear. All right, moving on. This guy, looking at these numbers, I can see that this is being divided by 3, or another way of writing that, timesing 1/3. So that makes this definitely geometric. This one I could see I'm going down by a little bit. Looks like I'm going down by 7. I'm adding 7. That makes this arithmetic. This one's going to be straight line. Whoops. It's going to be going downhill like this. This one starting at, never mind. One is straight, one is curved. All right, moving on. This guy, Stephanie's hair grows 1 inch every month, +1, +1, +1. That makes this linear straight line. All right, this one, car runs 3 miles on Monday, 2 miles on Wednesday, 5 miles on Friday. These are not going up or down by the same amount. So this would be neither. All right, this one, as soon as I see a percent is that curvy exponential. Percent curvy, it's going to be exponential. All right, this one going up by 500, going up by that 500. This one would be linear if I cut that one off. Linear for that one. All right, moving on. This one, we want to see where the solution is. So again, looking at these numbers, looking at these x numbers, determine which is bigger. This is bigger. There's my pattern. G of x is bigger. As I go to the right, 4 is bigger than -1. To the right, 5 is bigger than 3. But this next switch right here, this switch, I could see now that 0 is more than -1. -4 is more than -6. But then right here, another switch. Now, this bottom number, -4, is bigger than -5. -3 is bigger than -6. Once I find those switches, I use these numbers on the x-axis to describe where that switch is happening. So between -1 and 0, and then 1 and 2. So the only ones that show between -1 and 0 and 1 and 2 is this one right here. All right, do it again. This one bigger to the right. 4 is bigger. But then here's my first switch. So I then use these numbers to describe that switch between -2 and -1. That first switch from bigger to smaller. Now as I go to the right, bigger, bigger, bigger. But then right here, here's the last switch. So between these two numbers on the x-axis, so the only one that shows between -2 and -1 and 2 and 3, I believe would be this one right here. All right, there are no other problems. So good luck on this. And then again, always with a little grain of salt. I could have made some simple mistakes. Good luck.